24715. That's 24715 29th Street, Gobles. And we're going to go through some of the things that we discovered during the uncovering process, uncovering of the drop ceiling, taking it out in the structure. This house was moved from its original foundation, which was about 150 feet forward on the property, to this new ICF foundation that we see all around us. But not without some inherent problems. We're going to go through those one by one. The majority of the problems that we encountered were load-bearing issues and placement of load in areas without the proper footings, and also some very dangerous things that we uncovered as well, such as the thing that we're going to start with, which is this I-beam here, which carrying the weight of the entire structure above it. Let Patrick explain a little bit. We'll kind of go back and forth.
So presumably there was a foundation wall in the original location that's no longer there. It wasn't adequately tied into these joists here. It's sagging a little bit, and it's also, it appears, based on this large crack in the slab right here, that stems from this post right here. It's carrying the load of the first floor, the second floor, and the old roof. So all of that's bearing down right on this one point right here. And I don't know if you can get a look over here, but none of it was actually sitting or resting on the foundation here. All of this, this original beam across this wall here, at the top of this foundation wall, all across here, it was completely eaten away. And as you'll see in some pictures that we'll attach, that beam was known to not carry any load. It was a lot of termite damage in there, and it was hollowed out by the termites. And what the company who brought this, moved the house, stuffed some treated 2x4s up in the cavity to try to fill those holes, which I don't think that really helped.
So this whole area, what he's saying, this whole area right here was eaten by carpenter ants and termites. And the reason is that there was a ledge. The foundation was built too big. The foundation was built about between 3 to 5 inches wider than what it should have been, which created a ledge, an outward ledge that water sat on. And so that invited the pests in to eat up big areas of the foundation. That's one issue. So another issue is how all this weight was placed here on these inner posts that have no footings underneath them. There's nothing underneath it. So instead of putting it on the brand new foundation they built, which is right here, this brand new foundation, instead of setting up a proper beam to go and hold all that weight up, they decided to put these surface mounts and this steel I-beam underneath it. And we're about to show you above how that carried the weight of not only this floor, but the second story and the roof system as well was bearing on all this. And so hence the immense, the opening up of the foundation right here with this big crack. It was continuing to move, obviously. So while we're in the same area, let's talk about this LVL beam here. This is original equipment. This is what we found when we opened up the drop ceiling. But not only that, what we found right here at this level right here was a wall before that was built. So this was all hidden inside walls. You couldn't see any of these upward pilasters that were put in. They were carefully put in and integrated into the room. We'll show you the pictures that are going to be to illustrate that. So this was all hidden inside of, you know, very nicely finished out rooms and whatnot. However, once again, no footing. And look over here. They could have ran it into the ICF and actually bared some weight, but they cut short. Look, 2 inches. And here we have a foundation. So instead of bringing that across, they held it up with this. And then they put this little wall in here. So there was kind of a corridor in here before that did nothing. There's a corridor, and then we go into this room in here. So it really didn't make sense, this whole area, how it was put together, but what really didn't make any sense is where they put the weight, which is incorrect. We found where the original inspector, I believe his name is Haas, H-A-A-S, in 2003, pointed out these same anomalies that we're pointing out. What we can't find is how they rectified them. We can't find any documentation, and they're not able to provide any documentation here in Almena Township. They don't know how the situation was rectified. Obviously, it was not rectified. That's what we're here doing right now. So this, we're looking over here adjacent to this area. We've already replaced all these floor joists right here. So this is another area. We're going to talk about how, and you'll see in the photographs that these floor joists were tagged into a ledger board that really wasn't. It wasn't connected to the outer rim joist at all. So there was some 2x4s that were nailed in underneath it that was holding this whole floor system up. That whole floor system could have toppled down on someone's head at any time. So Patrick, you want to explain that situation and kind of how it was?
Yeah. So there was some blocking. There was some blocking that came out at an angle coming this way and nailed. It was nailed to the old beam. I think there were 5 or 6 of them across here.
Yeah, we have the pictures.
That was
Pictures document it really well.
But that's what was holding up the 2x4. That the joists that were sistered on. That's how those were held up. And we had a similar situation on the other side too. So it was not a safe situation for the water coming down on this floor system.
We also had a fireplace hearth that was sitting on top of rotted material as well. So hence the boilerplate. We took all that hearth out because it was 2.5 inches recessed down in the floor. You can't have it as a bathtub. It's got to be up at the same level as the floor. So raising that all up, in the scheme of things here.
One thing to note here is this little built-in unit. It's a gas fireplace. Was vented out incorrectly. This is not rated as a direct vent fireplace. This is just a standard unit, and it wouldn't have to be vented all the way up. They chose to vent it out as a direct vent fireplace. So that was definitely a wrong move there.
And when he says direct vent, what he means is that it didn't go up into a full-length chimney. What it did is it just protruded through the masonry. And we'll go outside here in a minute and show what that means. And there's just a weatherhead on it. So there's actually no chimney. So they actually vented this out like it was a wally. That's a big no-no. So that really is a fire code issue, and that's a serious fire hazard. Also a carbon monoxide hazard, because if any snow were to build up in front of that direct vent, you may not wake up. So let's go outside and take a look at it. Once you stop. Okay, so where this block's cut out, that was where the direct vent came out. So it was just a weatherhead, a hood, and again, all I had to do would fill up in snow in front of it. You start your gas stove downstairs and fill a place up full of carbon monoxide in no time. We didn't see any protective measures against that, or any kind of fail-safe measures. So as you can see, we've taken the fireplace all apart from the exterior, stabilized them, we're putting real triple walls in, and we're putting materials that meet fire code and that have the proper engineer stamp on the drawing as well. All right.
All right. Okay, so I also wanted to point out this LVL here was kind of notched into a triple 2x8. Not quite sure why, or 2x6. Not sure why that was. Oh, it is 2x8. Not sure why it
You can
was
see right here.
notched in there.
See that big crack in it?
Yeah.
That's how much weight is borne on that area.
Yeah.
This was already, it was highly compromised.
Yeah. The other thing I want to point out, and I don't know if you can get this on camera if you step back just a little bit. You see the metal up here? That's a cold air return or a return for the air handling system. And given that I took all this portion of the return system out, and I had to cut it out from above the LVL, which means this LVL was a second thought because everything was in, all the new mechanicals, all the electric, all the plumbing was in before they decided to put this LVL in here. Maybe they realized that nothing was holding up the front of the house.
So look at how stressed these were. These are on 24 and scant centers.
Right.
This is only a 2x8.
Yep.
Yeah, it's a real 2x8. But I'm assuming they put these in because these 2x8s that are on 2-foot centers, and this is a 24-foot span, by the way.
It's a long span.
It's a long span for a 2x8 on a 24-inch center. So you know that was sagging, and that's why they put this in.
Yeah, but they did it after the fact. They did it after the fact, which...
And it should have had a proper pilaster, should have had a proper footing down in the floor. But what we got, look, surface plate. Look at it, this is the surface mount. Here's the plate. It's not on a footing. And so we're about to cut all this area up, and that'll also be, we'll take some photographs and some video of it when we cut it up, just to show also, you know, here's a cross section of it. So you can see there's no footings under these major load-bearing points, holding up thousands of pounds of weight, especially this area over that we talked about first. You know, who knows how much weight is on it? You got 3 full levels on it.
And the other thing we wanted to point out here was this LVL is offset to the load, the major load right above here was the foyer, and then the second floor bedroom partition wall that was supporting the roof system. That's about 16, 20 inches over from this LVL. That's the location. And if you look from the stairwell this way, you can see that the LVL is holding up, but then where that load is bearing down, you can see the joist dip down dramatically.
Let's go take a look at that.
Yeah, right here.
Tremendous amount of weight.
Split right here in this joist right here.
Yeah,
And so
let's
that's
put a
where-
spotlight on that. For their workflow sake,
Okay.
I want to
Okay.
show everything that was sitting on this LVL. Just everything that you just talked about. Let's go look at that. Okay, so let's just review what he just said. This wall right here, which had the pocket doors in it originally, is offset in this direction by about 1.5 foot. Okay, so about right in here down below us is where that beam is. And so we have the weight. If you look above us, you have another broken up span by this wall that's pushing down on that one. So again, you have that same span that you have downstairs. And look, some of them have been sistered and they've been repaired because there was a tremendous amount of load on these, flexing it. We have been shouldered with the task of fixing this, which basically we're going to remove all of this. Once we stabilize the exterior walls, we're going to have to remove all of these floor joists and rebuild this whole area, including the stairwell, from the basement all the way up with brand new load bearing. Our load bearing
New
components are going to have footers underneath them wherever we're holding up, the weight of these areas. That calls for a proper footer, and we're also going to document what that looks like, and we will be documenting that with the local inspector. We have gone through this project with the local building inspector, and all the anomalies that we're explaining in this video were also explained to the local building inspector. And we're going to be asking him to post-inspect the repairs that were originally pointed out in their 2003 inspection. And these are all the anomalies that we found. Basically, we're fixing everything that should have been fixed, and we're documenting the before and after, and we're asking our inspection services, we're paying for the extra inspections on that to document the before and after effects. That's how that works.
And
So
then there is also another wall on the second floor directly above this. All those walls have been removed upstairs, and new trusses have been put in place of that. So there's no more load bearing on this wall, but there was originally when we first started.
And then we're going to go upstairs and we're going to show how this area here that we're talking about below that has the steel beam, how all of these floor joists right here are tied into one 2x8. And that's what these are pushing down to that steel I-beam downstairs, these pillars right here, and was holding up all of these floor joists up that were attached to this 2x8.
And from this corner here, this outside corner, all the way to the outside corner on the other side, out there, these are at the same elevation, and this is about 2.5, 3 inches down in the middle. So it has sunk 2.5 inches minimum right there.
Hence all the variation in the second story floor. Actually, the variation too in the first floor, because we had probably just as much here, 3.5 inches of variance in the floor. So we're setting everything to the exact same laser level right now. This brand new floor is like standing on top of a steel structure.
Yeah, it's at the same elevation as the new kitchen floor and the new kitchen joists and everything that we put in there.
So these are our new benchmarks that we've established, and the entire structure is being built to these benchmarks. All right, let's go upstairs. Let's look at where the rest of the weight. So just so we can follow through with this I-beam in the basement. The I-beam is below us right here. Again, one 2x8. All these floor joists with this incredibly long span tied into that one. And then up above us, there was a wall, and that wall had trusses sitting on it. A 20-foot span truss was sitting on top of that wall. We're going to go look at and just see where that was located. This is called a girder truss. This girder truss is now holding the weight of what used to be a 20-foot span truss that was borne on a wall that was right here. Now, again, this is that point we just looked at underneath us. That 2x8 is carrying on through, and those pillars are carrying that load down to the I-beam in the basement. That's borne on 2 pillars. So imagine all of this weight, the weight of the roof structure, the weight of the floor, the weight of the first floor, all of that borne on just those 2 little points that aren't properly anchored in the ground. There's no footers under those areas. So we've thus remedied all the load-bearing issues up here because we put this girder truss in. That girder truss transfers all that weight now to these points, and these points we have built all the way to the foundation, and they are solid. They're rock solid.
Yeah.
So we're pushing on where we should be pushing, which is the ICF foundation. That's where the weight is supposed to be, and allegedly, I'm assuming the original inspection services should have caught that. That they basically, they put an ICF foundation, a new foundation, but half the weight of the house wasn't pushing, sitting on it. they decided to put half the weight of the house on interior walls and pilasters that had no footings underneath them. And that's really, in a nutshell, the majority of what we're looking at here.
I do want to point something out, that this girder truss is actually resting on this wall right here and not on this wall. We're still reframing this and putting a new location for this window. I just wanted to make sure you didn't think that these were buried below. This section right here, we're gonna, when we remove this, we're gonna double up this 2x4. But right now, that is bearing the weight here of the girder truss.
This is like a trampoline. This is a perfect representation of how basically all the floors throughout the house. If you got 2 or 3 big guys right here and they jump up and down this point, you could break this.
And they've got a post and beam set up right here right now, so,
Yeah, so
you're not getting the full effect.
It's breaking that span up somewhat. So here's our new stuff. Here's the benchmark that we've created. This room is brand new. Again, all the weight now is pushing onto the ICF foundation. Okay, we're in the basement now, and we're on the northeast side of the house, the northeast corner, very northeast corner of the house. And as you can see right here, you can see all this water damage. And this was all full of black mold in here too, by the way, in this corner and in the opposite corner at the other side of the house. If you look through this window right here, you see that there's a deck that's on there. You'll notice that there's a deck up there they built, and it actually has a soffit material that's installed on the bottom side of it. And so you would think they would have had a waterproof membrane or something, you know, and have it properly flashed where it came against the house. Unfortunately, that wasn't the case. It was actually routing water into the house, the deck. And as you can see too, you know, just very shoddy work, and these headers and stuff above the doorways. Here a cross section of it over here, torn apart. This doorway sags so heavy. This is a double 2x10 that's on this. You would think that that's enough, but the way that it was positioned and the way that this wall system was positioned, it actually wasn't bearing down on this at all. It was actually bearing down on an angle, so that, and it was scary because we realized that we have all the weight above us, and some of these 2x4s here weren't actually bearing at all any weight. So hence you see all these structural screws. We're also going to be we got this dugout here, and we're going to be installing another double set of yellow pine 2x10s sandwiched together with a brand new header tagged in. We got plenty of space in there to do that. And then we will put rebar stem to stern. If you can look back in here, from over here, you can see, well, their ICF. Where's my ICF? Where is it? So there's a big hollowed out area, and that's a no-no. You can't have that. So we're going to put some re-rod back in there and sturdying up the ICF through this area right here. We have no choice. We got to do what we can do. So that little stem wall that was built inside of that ICF, we're going to be extending that, and so that this whole area actually bears upon the header across this the way it's supposed to. This door is getting eliminated too in the scheme of things, so there's going to be a lot less weight bearing on this doorway when we're done. All right. So in the original, after the original move, these floor joists were put in here as they were originally like a sistered together mess. This whole thing, you'll see in the photographs that will supply the before, how there was a big beam in here, and that was sitting on top of this. They had to push this up all together because the floor joists were actually ran into the center, again, bearing on these hidden columns that were hidden in the walls. No footer underneath them. These are surface mount type deals. And this was holding all that up, basically, and it was sagged out. It's pretty scary. Yeah, they were sister together. They were on angles. The kitchen floor was just an absolute nightmare to walk on. It was like a trampoline, basically.
And one of the things that kind of illustrates the type of workmanship that we've been running into on this project is the kitchen sink drain came back this way to clear this LVL and go over here and then drain. But in the same line, the very same 2.5 inch or 2 inch line, the washer and dryer bill from the laundry room came down here and came this way and met at the same spot to go this way. But there were two Ys going opposite directions. So what was occurring was when you tried to run the sink and you had the washer going at the same time, they would be fighting each other for drainage. And I mean that was just an obvious.
Oh yeah. So they're bringing water from this kitchen sink over there to come over here to go back on a sharp angle back this way. And this was coming into it as well. And that, so if you use the kitchen sink while the washing machine was draining.
And as Dale was talking about the sister joists in this area here.
By the way, this mess right here on the floor is all the product of that. This is some of the better stuff that we took out, so we saved it. But we have the beams and stuff that we saved that were just an absolute mess. The whole thing.
Yeah. And so we've got this LVL here, and I'm pretty certain this was an afterthought as well when the rest of the LVLs went in, when they realized they had to have more support for these flooring systems. But this goes up at an angle to tie this LVL with being somewhere in the center of this 24, 23 foot span right here. And that's where it ties into this this triple 2x8 that was notched out in several places.
So let's just review what he just said. Let's just kind of break this down so that in layman's terms. In layman's terms, what they did is they came in here and we had these big beams that were tied into each other. Here's the original big beam right here, still up in place. This one actually does go all the way across, by the way. This one actually does hold up weight and go all the way across. And the other one was teed into it. And so it was sort of like a T. And then it came to another T at the end of that wall. And they were just filling in and putting in pilasters and pushing up on this thing however they could to keep it together so that they obviously didn't have to replace floor joists. And so that's how they ended up with this absolute mess, this mishmash of, okay, we got to push up over here. Well, let's put an LVL on an angle over here. It's sagging over here too. Let's notch in over here. Let's set it on the top of this top plate here, because this is sagging too. That's literally what they were doing here. Same thing with this. Look, here's another pilaster, another surface.
And then you also have a place where they drilled down to put a post and either moved it or decided that they needed to have more room for the HVAC. I'm not sure why that's there.
So that's it in a nutshell. We're going to go outside now and we're going to show how they left us a ledge, how they built a foundation between 3 to 5 inches too big in every direction, and that caused a ledge. And on that ledge, it was not water sealed properly, and it held water, and so that's why we had an infestation of carpenter ants and termites, in which we did hire a pest control to assess the situation, diagnose what they were, so that we could officially log that in and the cost of that. So that has subsequently been, all that wood has been removed. We have placed the loads in the proper locations, except for these areas that are about to be gutted. We're going to take out all of these floor joists and put brand new in, just like we've done over here. The proper dimensional stuff, the proper engineer stamps, the proper pilasters where they're located on the drawings, and we're asking our local inspectors to take a look at those and verify that we've placed the loads in the correct locations. All right. So speaking of ledges, we left us a ledge here too, and this variates. This ledge right here, we're at about 4.5 inches, 4.5 or so. It angles back over here. It's back to about 3.5. It goes down to about 3 right against, right here. Right there. So what they were doing, they were allowing for a variance, and and so they actually built a lot of variances. The wall is not necessarily straight. We left this intact. We left this purposely to show what they left here. So here's their new ICF. Here you go. There's original framing. So we're about 4.5 inches out right here from the framing. Here's your framing. Yeah, 4.5 scant here, and then over here in the corner, inside corner, it tapers inward. So they were leaving that variance, so that they could set the house on it. I'm assuming was the reasoning, but you can't have your foundation out here 4 or 5 inches out more than the doggone house, not without having a problem.
Yeah.
And leaving this, look at this ledge. This is what held that water. They held water. This is all the flashing they had. And they had some siding, some vinyl siding coming down over this. Well, that water was getting all in here and collecting in here, and they were just having a field day with this. You'll see in the photographs that this was just completely eaten. Especially the porch. The porch was just gone. It was only being held up by 2 little toothpicks. We're holding the whole roof up on that. Scary.
They had fiberglass bats in there. And when I took the fiberglass out of the ceiling in this room in here, they were just drenched. I mean, they were just soaking wet, and it hadn't rained for, a week or so, and they were just soaking wet. It just took on a lot of water.
Speaking of water, this area in here, this ground area in here is pure clay. They backfilled this foundation with clay. And this inner corner right here has been a major leakage point. This is an ICF foundation over here, and it had the same ledge. Everything. The whole house follows that ledge. It has this ledge here. Yep. So you can see we're at about 3.5 here, but we've replaced this with brand new. This was all rotted, so we'll show you in the the first series of pictures. Let's show this beam pocket here too, how these beam pockets were put in. When I say beam pockets, the house was moved off of its original foundation. So in order to move the house, you have to push a steel I-beam through and carry the weight, and to be able to lift the house up at a perpendicular trajectory. And that's why these were left, these big openings. But they never filled them in. It's just a big hollow. And they spray foam, they put like an inch of spray foam here, but still you have a big breach in the foundation. They didn't beef these areas up at all. There's no header, really just big open beam pockets. So that's another thing that we're dealing with. It's just compromised compromised load-bearing areas galore on this house.
You see, this is where the beam pocket is. So where this metal flange is, that's where they have concrete. So there's concrete behind here, nothing behind here. So
Right.
This is a beam pocket.
And so when we try to draw a straight line here, look what we get.
Yeah.
Hold this part of the trip so you can see if this doesn't follow a straight line. This is out almost an inch further than that area over there.
Yeah. And so
So this is not a straight line.
See, we're over an inch there, and this side is just about flush. So they didn't have any lateral support when they poured these to keep them true to one another, keep them flush, and so they traveled a little bit, and an inch is not a little bit. An inch is a lot for that foundation to move.
Yeah.
And it's like that on a lot of these beam pockets. They're just not lined up. They're on one side to the other. They're offset. That's another thing I noticed.
Yep. All right, so this, notice that we have new wood in here. This was all eaten up by insect damage, so we'll pull those photographs and couple them with this. So this deck was also bringing in water into the foundation, but you can see this big ledge here. We're at 4 inches on this side. About this, about the same ledge. So, and below it, there's also beam pocket, another misaligned beam pocket below it. All the standard stuff, that we found around this foundation. So we were holding water on the ledge. We had, insult to injury going on in this corner. And obviously they knew because they stacked lumber in the areas that were rotted and had infestations. This here, if you're gonna have a ceiling on a deck below it, you should put some kind of a membrane and have this a non-penetrating floating floor sitting on that. So this is all nailed in. I think there's a bituminous membrane underneath it that they nailed down through. It was, again, that was holding water as well and bringing water in. The whole thing was going downhill.
You can see, that flashing only went up to here. You get any ice or snow buildup right here, and you can even see this is where a lot of the rodents were coming in and out of this spot here, which allowed direct access for any water and moisture get in down in there.
Yeah, so the remedy is we're going to take this off here, and it's got an ICF foundation that comes out and forms an L here, so we're kind of working within the boundaries of that. So we're going to actually put a PVC welded membrane with a floating floor on top of that, and that's going to actually shed the water off in that direction, and that's going to run over into a crock in the corner of there. So, which leads me to another issue, is in this inner court area, there's not a 1% grade going outward. So the whole inner court area that they cut out in here is holding water and was also bringing some amount of water, during certain times of the year. I'm sure when they had a big snow buildup or whatever, it was coming in those doorways and whatnot. So we're going to have to cut that down about 3 feet and make everything go in that direction over there into a cement structure. And then what we're doing is we're putting a big drainage under that road that's going to go over there to that embankment. That's going to take all this water and push it over there. That's about the only thing that we can do.